Try to solve this question. So in this question it's been asked that a gaseous hydrocarbon weighs 0.70 gram and contains 0.60 gram of carbon. So we have to find the molecular formula of the compound if its molecular weight is 70 gram. Definitely molecular weight is 70 and atomic weights of carbon and hydrogen is given, which is 12 and 1 respectively. Okay, once again it's very simple question. So how do we proceed with this type of question when we have to calculate the molecular formula? So it's very simple. We have to form the first table. So it says the element, then comes the percentage composition, then comes the atomic weight, then comes the relative number of atoms, and then comes the simplest or simple ratio. Okay, simplest or simple ratio. The elements which are shown over here are carbon and hydrogen. So I'm gonna write carbon over here and hydrogen over here. Now we don't know the percentage composition, to be honest. Okay, it's not clearly mentioned what is the percentage composition, but can we calculate? Yes sir, we can calculate, because the gaseous, it's written that gaseous hydrocarbon weighs 0.70 gram. That's the total weight is given, and also it is given the 0 out of 0.70 grams, 0.60 gram is a carbon. That means 0.10 gram is a hydrogen. So can we calculate? Yes sir, we can calculate. So how do we tackle this type of problem? So what do we do in that case? We can write down that a gaseous hydrocarbon, which is 0.70 gram, okay, contains 0.60 gram of carbon. Then 100 gram of gaseous hydrocarbon would be having x gram of carbon. Okay, this is basically we are trying to calculate the percentage, and why we are specifically using 100 over here, because percentage is always out of 100. So we are trying to calculate the percentage composition. Okay, therefore the value of x would be equal to 0.60 into 100 divided by 0.70, and when you calculate this fraction, you get the answer is equals to 85.71 percentage. Okay, now we got the percentage of carbon, which is 85.71%. Now as there is only two elements, you can simply do the 100 minus 85.71, where you will get the answer is equals to 14.28 percentage. Okay, it is 14.28 percentage. If you want to go if you want to proceed with this type of this, you can go with that as well. Okay, atomic weight of carbon is 12 and hydrogen is 1. In order to calculate the relative number of atom, what do? We divide the percentage composition by atomic weight. So when I divide 85.71 by 12, I get the answer is equals to 7.142, and when I divide 14.28 by 7.142, I get the answer, I beg your pardon, it's 1. So I get the answer is equals to 14.28. okay, and once we calculate the relative number of atoms, what do? We select the smallest number and we divide it and divide all the relative number of atoms by smallest number, which is over 7.142. So what do we do over here? We divide 7.142 by 7.142, which is answer is 1, and when we divide 14.28 by 7.142, answer becomes 2. Okay, so as these are simplest whole number, we can write down ratio of carbon is to hydrogen is nothing but the 1:2. Okay, is 1:2. As these are the simplest whole number ratio, I can write down my empirical formula as CH2. Okay, but we have to calculate the molecular formula. Okay, we have to calculate the molecular formula. Okay, and this is the empirical formula. So how do we proceed for the molecular formula? So in order to calculate the molecular formula, we multiply empirical formula by n, We have empirical formula, but we have to calculate the value of n. How can I calculate the value of n? So n is equals to molecular weight divided by empirical formula weight. Okay, do I know the molecular weight? Yes sir, we know that because it's given in this question, which is 70. Okay, empirical weight, molecular weight is 70. Okay, perfect. So if the molecular weight is 70, what is the empirical formula weight? So as we have the formula for the empirical formula, we can calculate the empirical formula weight from it. So empirical formula weight is equals to 1 carbon plus 2 hydrogen, which is equals to 12 plus 2 into 1, which is nothing but the 14. Okay, which is nothing but the 14. Therefore my value of n becomes n becomes 5. 14 5s are 70. Okay, therefore n is equals to 5. Therefore molecular formula is equals to 5 into empirical formula, which is CH2. Okay, which is CH2. Therefore my molecular formula becomes C5H10. Okay, my molecular formula becomes C5H10. Okay, let's go through this question once again. It was very simple question. That was said the gaseous hydrocarbon contains 0.70 gram and it contains 0.60 gram of carbon. Therefore we calculated the percentage composition from it. So we said that if the gaseous hydrocarbon has 0.70 gram of out of 0.70 gram, if 0.60 gram is carbon, then out of 100 gram it would be the x gram of carbon, and we calculated the percentage composition of carbon. When we subtracted the percentage composition of carbon from 100, we got the percentage composition of hydrogen, and we calculated the relative number of atoms for carbon and hydrogen both, and by dividing it with the smallest digit from the relative number of atoms, we got the simplest whole number ratio as well. Okay, then we found the empirical formula, and then we found the value of n. When we multiply the value of n with the empirical formula, we get the molecular formula. Once again, if you still have any particular doubt regarding this question or any other question in general, you can comment your question, your doubt into the comment section, and we will try to make a dedicated video towards your doubt. Till then, keep on studying and keep on asking doubts.